Hi students, happy to see you again. Today we are going to see phosphate as an anti-corrosive agent or phosphate conversion coating. Okay, an effective corrosion inhibitor in water as well as any coating system. Okay, this is presented to you by Dr. S. Rekha from RMD Engineering College, Chennai. Let us define it. What is phosphate? PO4 minus. Okay. So from phosphoric acid. Phosphates are salts or esters from phosphoric acid containing PO4 minus. Okay. It acts as an anti-corrosive agent. Phosphate functions by chemically reacting with metal surface. So these are called conversion coating. Chemically reacting with metal surface and forms a coating on the surface. Okay. So this coating is insoluble and so it forms the coating on the surface which forms the iron phosphate. These layers act as very protective barrier preventing the penetration of moisture and oxygen, that is protects it from corrosion. So phosphate as an anti-corrosive agent, the chemical compound phosphates are the chemical compound used to prevent metal corrosion by forming protective insoluble phosphate layer on the surface. So passivation layer, what it does, it reduces the oxidation, enhances the adhesion for coating and improves the durability of the coating. Okay, so this is the main purpose. So it acts as a corrosion inhibitor in the industry, especially used in automotive industry, construction industry, and water treatment plants. Let us see the bark parameters. So this bark consists of phosphoric acid, typically 5 to 20 gram per liter. Zinc phosphate may be ranging from 1 to 5 gram per liter. Accelerator used is sodium nitrate, which ranges from 1 gram per liter. Little bit we add no to accelerate the process. So phosphoric acid, we need to maintain a pH of 2 to 2.2 to 3. So accordingly, we'll add the phosphoric acid. So phosphoric acid will become the pH adjuster. So temperature ranges from 40 to 60 degree. In certain cases, even it goes to 80 degree Celsius. Okay, immersion time is just 10 minutes. Application method may be immersion, spray or brush coating. So coating property forms a corrosion resistant phosphate layer, enhances paint adhesion. Same property as we have seen for molybdate coating. So what is the chemical reaction behind this process? Okay. So mild steel or zinc coated steel is taken, that is galvanized steel is treated with this phosphate solution. So phosphoric acid with zinc. So zinc starts dissolving into the solution forming zinc phosphate and hydrogen gas is liberated. And this zinc phosphate in turn start depositing as coating over the surface with the taking up the water molecule. So it deposits over the zinc surface, it deposits. So we have steel underneath, over that we have zinc coating, over that we have the second layer, we have the phosphate coating. What is the chemical reaction of phosphate inhibition? So iron 2 plus, simply we can say iron phosphate giving you iron phosphate, which is a protective layer. So it forms insoluble iron phosphate layer, act as a barrier to oxygen and moisture, that is corrosion resistant, significantly cut down the corrosion process. So process, so it involves surface cleaning, phosphate treatment, formation of passive layer, and then we have monitoring, that is used for appropriate concentration, everything we check over that. Okay. So the process can be explained with the help of a diagram so that you can understand in a better way. See, we have the surface here. Okay, maybe the steel surface or the galvanized surface. So it is taken as the rough surface. So the rough surface, we have the active sites. We have the round balls, right? So that becomes the active site. Now this surface is dipped into a phosphate conditioning solution, phosphate bath. Okay, so what happens? Zinc phosphate grains are formed initially. Okay, on the surface we get zinc phosphate, And slowly this in nucleation, when it has started, slowly it process or moves to the other part of the surface. So first layer, primary coating, is formed on the surface. Okay. Now once the primary coating is formed, the continuous dipping into the solution leads to the secondary layer. Secondary grains are formed. So secondary grains, when they are formed, it grows the thickness of the conversion coating. Once it is coated, then you have to wash it, dry it, and if you see, you have the micro cracks in it. If wanted, you can go for sealing treatment, as we have seen in molybdate coating. That is, you can give a apply a paint over the surface, over the surface, or you can dip it in hot water so that it becomes sealed. The surface get sealed off. The complete process of phosphating can be explained by this flow chart. So first process is cleaning the surface, then rinsing with water, then activating the surface. So for activating the surface, one example is you can dip it in titanium phosphate solution for just for 30 seconds. Okay. Then rinsing with water once again, and then undergoing phosphating process. Okay, immersion for 10 minutes, okay, into the bath, then rinsing it. Then if optional you want neutralization, you can neutralize it. As we know, phosphating is acidic bath. So if you want to neutralize it, you can have a light basic bath in which you can dip it to neutralize it. Again, you can wash it with water, then drying it. Okay. So if you want to fill the micro pores which is present on the surfaces, so you can apply the supplement coating. So the supplement coating could be varieties of type. We can have chromate coating over the surface. This is for just 30 seconds you are applying. Okay. You can give a epoxy coating, you can give a molybdate coating or nano coating, or just you can apply painting. So by this you can end the process. So this becomes completely foolproof for corrosion. Okay. It's 100% corrosion resistant, it turns out. Advantages of phosphate coating: it is cost effective and easily available, effective in preventing corrosion on steel and iron, compatible with other inhibitors like zinc. Okay, so I've told no why we have used zinc here. Zinc, purpose of using zinc in this bath is this zinc enhances the nucleation step, first step, that is nucleation step. And also if we add little bit of zinc in the bath, we have observed that the thickness of the coating is higher. Okay, so it is this phosphate coating is used in food safe formulations, orthophosphate, which is not toxic. Okay, enhances paint adhesion in coating system, so it is can be used as a adhesive layer, undercoat layer. What are the applications? So it is used in water treatment substance. It can be used in industrial and municipal piping. Phosphate conversion coating is given as an undercoat for painting. Cooling water and boiler water system can be used. In that also this type of coating can be used. Paint and primer formulations, in that also it is used. Okay, so already I've shown this comparison. Those who have not seen that molybdate coating, so let us see once again what is this parameter about. So three types of conversion coating we have: phosphate coating, chromate coating, and molybdate coating. So in this, which is the best? So we see toxicity, phosphate is also low, molybdate is low, chromate is high. First phosphate conversion coating ever emerged is chromate. Okay, so to why chromate has to be replaced with phosphate or molybdate? Because see here, environmental risk is high for chromate. Okay, so whereas if you go for phosphate coating, it is moderate. And if you want 100% sustainable development, then you can go for molybdate coating. Film durability, phosphate is moderate. See here, chromate, it is good, but we want to have environmental friendly, then durability comes down in phosphate coating. But whereas in molybdate coating, it is environmental friendly as well as durability is also high. So out of the three, best is molybdate, second best is phosphate, then it is chromate. Advantage of dual coating. See here we give zinc ion is we are using, no? So zinc ion reacts with molybdate to form zinc molybdate on the surface. Then iron or steel surface also forms iron molybdate, which passivates the surface. So combination of these two completely stops the dissolution of anodic process. Okay. So in phosphate coating, little bit of zinc is added so that we have the dual coating. I said no, the thickness of the coating increases easily. Zinc helps in initiating the nucleation process. Thank you, students. I hope so you have understood the concept very well. So compare and study to remember things. So we have learned about phosphate conversion coating, as well as in another video I have given molybdate conversion coating. So compare and learn. Thank you. Enjoy learning.